everyone. Thank you very much for signing in and watching my live stream. I'm Mr. Matt, and this is Dr. Tot. Dr. Tot, cookie for class? Very good. And welcome to SAT, ACT Prep. So we're going to continue with some miscellaneous practice problems today, and I wanted to concentrate on some data interpretation questions. So we're going to look at pairs of questions, 3 pairs of questions focusing on specific subtopics. First, we're going to look at some charts, and then we're going to move on to some pie graphs. So let me share my screen with you. And just a reminder, this is a live broadcast, so there's a little bit of a delay with the iPad, but I'll try to reduce that as much as possible. If you find these videos helpful, please like, subscribe, and share with your friends, and I'm here to help. If you have any questions, please post them below in the comment section. I'm also available on all of my social media accounts, which are linked in the description below. All right, so let's get started. I'm going to give you 6 minutes to look at each pair of questions. So because these are data interpretation, they both pertain to whichever diagram is listed. So we'll be looking at charts at first, and then, like I said, moving on to pie charts or pie graphs. So for 1 and 2, you want to refer to the information listed in the charts with regards to the number of items purchased per family and the cost of items at each restaurant. Number 1 asks, if the Smiths order from Sam's Deli, what is the total cost of their order? And number 2 asks, if the Wilsons order from Jenny's Cafe, what is the total cost of their order, including a 5% sales tax? So I'll give you 6 minutes. About 2 minutes in, I'll start to solve, and I'll keep track of the time in the upper right-hand corner and try as best as possible to update it every minute. Okay, so if we look at number one, we need to calculate the total cost that the Smith's order is from Sam's Deli. So we're going to take the number of items that the Smith's order, so the individual number of BLT sandwiches, turkey subs, and tuna wraps, and multiply them by their corresponding price at that restaurant. So 4 BLTs times their individual price of $8.40 plus 13 turkey wraps times their individual price of $6.70 plus 6 tuna wraps times their price of $8.80. If you do that calculation, you should get $173.50, which is answer selection C. Now for number two, you do the same process for the Wilsons, taking the number of each item and multiplying by that item's corresponding price. But then there's an extra step because they say they actually ask, the question is asking, what is the total cost of their order including a 5% sales tax? So that means that you're going to have to increase the total cost by 5%. So there is a key difference here between taking a percent or increasing and decreasing by a percent. And it's really pivotal to understand the difference between those concepts because they are completely different. Taking a percent is multiplying just strictly by the decimal version of that percent. So taking 30% is multiplying by 0.3. But when you're increasing or decreasing by a percentage, you have to take the fact that you're starting with 100% of whatever you already have. So if I have 20 apples in a basket and I'm increasing those 20 apples by 5%, I already have 100% of those 20 apples. I'm not starting with 0%. So that's what can be a little bit tricky here. So what you want to multiply by is 1 plus or minus the intended percentage change. You add if you want to increase, you subtract if you want to decrease. So if we want to increase by 5%, we need to multiply by the decimal equivalent of 100% plus 5% because we already have 100% of the total bill, which the subtotal here turns out to be $237.40. So you already have 100% of all of those $237.40. You need to increase that by 5%. So you're going to multiply by the decimal equivalent of 105%, which is 1.05, moving that decimal place 2 places to the left. If you do that, you should get an answer of $249.27. Let's look at questions 3 and 4. So these questions pertain to a new chart. And in order to fit all of this in here, I'm going to write answer selection D for number 4 here. It's just 5%, but just so you can see it, because it's cut off in the screen, but D is 5% for number 4. Question 3 asks, if the Johnsons order from Sam's Deli, what did they pay if they used a 20% coupon off the total cost? So kind of the opposite of what number 2 was doing. Number 4 asks, if the Wilsons originally order from Jenny's Cafe, but then cancel their order and instead order from Sam's Deli, then which of the following is closest to the percentage change of their total cost? So I'll give you 6 minutes, and about 2 minutes in, I'll start to solve. Okay, so looking at number 3, the Johnson's order, so if we take the number of sandwiches times their individual cost, we're going to get 18 times 6.5 plus 5 times 8 plus 17 times 9.8, just rounding there from the price to integers or to the tenths place. So if you multiply all of those guys together and then add their products, add those products to make a subtotal of $323.60, but they have a 20% coupon. Excuse me. So this has the opposite effect of the tax. If you tax the subtotal, it's going to increase the total, or increase the subtotal to the total. But if you have a coupon, you're going to be taking money off of the subtotal, so the total would be less than the subtotal. So we're going to multiply by 1 minus 0.2 because we want to decrease by 20%. So 1 minus 0.2 is 0.8. Notice how there's a symmetry around the number 1. There's a reason for that. That goes to the identity property of multiplication, that 1 is the unchanging value. Anything times 1 is that same something. So notice how it's not a mistake that decreasing by 20% is the same thing as taking 80%. Decreasing by 30% is the same thing as taking 70%. Decreasing by 60% is the same thing as taking 40%. So there is this symmetry around the number 1 with increasing and decreasing by percentages. So if we do that, 323.6 times 0.8 is going to give us $258.88, which is answer selection D. Now for number 4, we needed to do the same initial process in order to find our subtotals. So I'm just multiplying the number of sandwiches times their corresponding individual prices to find, and then adding those values up to get subtotals for each from each restaurant. So that's where I got the $304.60 and the $289.70. But they actually asked me for which of the following is closest to the percentage change of their total cost, because they initially ordered from Jenny's, so that's my starting price, but then they canceled their order and ordered from Sam's. That's going to be considered my final price. So you do have to memorize the percentage change formula. I'm going to highlight it here in red. So you have to memorize this guy because they're not going to give it to you on the exam. It's not going to be in any formula sheet, and they will expect you to have memorized it. But percentage change is equal to final minus initial divided by initial times 100. So in other words, the value you end up with minus the value you start with, total value, quantity divided by the value you started with, whole quantity times 100. You have to multiply by 100 if you want a percentage answer. Otherwise, your answer is going to be a decimal, which is fine. You just have to make sure that you interpret it correctly. Oftentimes, they'll put the decimal answer as an answer selection to be really tricky. So you have to make sure that you move the decimal place 2 places to convert it into a percentage, which is what multiplying by 100 does. So if we calculate this, we have $304.60 minus $289.70. That's going to give us $14. Oops, need my pen here. I'll continue it down here. $14.90 over 289.7, whole thing times 100. So that's going to be 0.0514, and that is about 5%. Answer selection D. If you have any questions, then please let me know in the comments. Otherwise, let's take a look at the next pair of questions. And I'll list again, I have to list D over here. D is 96.5%, just so I can fit the information on the screen for you. Okay, so I'll give you 6 minutes, and about 2 minutes in, I'll start to solve. Okay, so number 5. If Michael Johnson from the Johnson family offers to pay the entire bill for all the families, how much more would he pay if he purchased the meals from Jenny's Cafe rather than from Sam's Deli? So the same process here, but now we just have a gigantic problem. One shortcut. Now, when you're entering values into your calculator, you do need to be really wary of parentheses, and usually I would always tell my students that whenever in doubt, make sure that you put in parentheses because it can change depending on the order of operations what the calculator does or interprets your input to be. But here, the calculator does strictly distinguish between addition, subtraction, and multiplication, division, at least if you're using a graphing or a scientific calculator. Excuse me. So here, you can just type these values directly in. So when I was calculating Sam's Deli, for instance, I just typed straight into my calculator 9 BLTs, or so just 9 times 7 plus 15 times 6.3 plus 7 times 6.2 plus 16 times 7 plus 16 times 6.3 plus 18 times 6.2 plus 12 times 7 plus 17 times 6.3 plus 14 times 6.2. If you type that all into your calculator, it'll do the order of operations correctly and return a total of $803.20. If you repeat that process using the prices from Jenny's Cafe, then you'll find a subtotal of $840.50. The difference between those two values is $37.30, which is answer selection A. Now question 6 asks, the total amount that Michael Johnson from the previous question paid when purchasing from Sam's Deli represents what percent of the total amount paid when purchasing from Jenny's Cafe? So you need to be able to correctly identify which portion of this conceptual fraction is the part and which is the whole. We can always think of fractions as some part over the whole value. Usually the whole value is the sum of the component parts, but it doesn't always have to be. Here, they're comparing Sam's total to Jenny's total, or not their total, but from those respective restaurants. So the subtotal when ordered from Sam's restaurant divided by or considered the part over the whole value of the subtotal of when ordering from Jenny's Cafe. So what we're going to do is we're going to consider Sam's subtotal to be the part and Jenny's subtotal to be the whole value in a fraction. And that's going to give us a decimal answer that ultimately we're going to just multiply by 100 to convert into a percentage. So we're going to get $803.20 divided by $840.50, quantity times 100, which is going to give you about 0.9556, which I'm going to round to 0.956, which multiplied by 100 will give you 95.6%. And that's answer selection C. If you have any questions, then please let me know. Otherwise, let's look at 7 and 8, and these involve these pie charts. So we have the sales in 2000 and 2010, both in millions of dollars for products A, B, C, and D, represented by these pie charts. Number 7 asks, which of the following is closest to the percentage increase in sales of product C from 2000 to 2010? Number 8 asks, the sales of product A in 2010 is what percent of the sales of product C in 2000? So I'll give you 6 minutes, and about 2 minutes in, I'll start to solve. So I'm very sorry. There was a typo with number 7. So my apologies. It should have been an increase of 65%. So we need to use the percentage change formula of final minus initial quantity divided by initial times 100. So we would take, if we're talking about sales of product C is the gray sector. So $7.6 million of sales in 2010, which is our final value, minus $4.6 million of sales in 2000 for our initial value, quantity divided by 4.6 million times 100. So 7.6 minus 4.6 is going to give us 3. 3 divided by 4.6 is going to give us about 0.65. Multiply that by 100 to get 65%. So that's number 7. Number 8, the sales of product A in 2010 is what percent of the sales of product C in 2000. So in 2010, product A, the blue sector, had $14.8 million of sales. Product C in 2000, which is the gray sector, had $4.6 million of sales. So 14.8 divided by 4.6 is going to give us 3.217. But notice that's a decimal answer because product A's value in 2010 is so much larger than product C's value in 2000. The decimal actually is greater than 1, so when we multiply it by 100, we're going to get 321.7%, which rounded to the nearest percentage would be answer selection A, 322%. So notice again, there's 3 different types of percent problems. Percent of, percent increase or decrease, and percentage change. So percent of is just multiplying by the strict decimal version of the number. 30% of something is that number times 0.3. 25% of some number is that number times 0.25. But if you're going to increase or decrease by a value, you have to start with 100% of whatever you have. So it's 1 plus or minus the intended change. Percentage change has its own formula, final minus initial divided by initial times 100. So you have to be able to clearly distinguish between those 3 types of conceptual pathways in regards to percentages because they're going to totally change depending on the question, and if you use the wrong conceptual method to solve, then you're going to get the wrong answer. If you have any questions, then please let me know. Otherwise, let's look at 9 and 10. And I'll write answer selection D for number 10 out. So D is 872%. So we have new pie charts for the sales of these 4 products in year 2000 and 2010. Number 9 asks, which of the following is closest to the percentage increase in sales of product B from 2000 to 2010? And number 10, the sales of product D in 2010 is what percent of the sales of product C in 2000? If for some reason you find some outrageous typo like before, please just answer it as a grid-in, but I am hoping, I'm hopeful that that won't happen again, but I do apologize about the last question. But I'll give you 6 minutes. After 2, I'll start to solve. So for number 9, we needed to use the percentage change formula, final minus initial divided by initial times 100. The percentage increase in sales of product B from 2000 to 2010, the final value would be product B in 2010. Product B in 2010 is 15.1. Product B in 2000 is 5.8. So 15.1 minus 5.8, quantity divided by 5.8 times 100 will be our answer. 15.1 minus 5.8 is 9.3. 9.3 divided by 5.8 is going to give us 1.6. 1.6 is a decimal. Written as a percentage, we'd multiply by 100 to give us 160%. So product B increased its sales 160% from 2000 to 2010. But notice what that means. That means more than what it already had, right? So it's 160% past its already 5.8 million. So answer selection C, 160%. For number 10, I'm sorry, it should have said the closest, which of the following is closest to the percent of sales of product D in 2010 compared to or of product C in 2000. So when I calculated this, we're considering the part versus the whole. We're considering part D in 2010 to be the numerator. Not part, product D. Product D in 2010 is 15.4. Product C in 2000 is 2.4. So we're going to have 15.4 divided by 2.4. That's going to give us a decimal answer, which we'll have to convert into a percentage by multiplying by 100. 15.4 divided by 2.4 is 6.41, or thereabouts. 6.41 times 100 would give us a percent of 641%. So product D in 2010 represents 641% of product C in 2000. If you have any questions, then please let me know. Otherwise, let's look at the last pair here for today. And again, I'll have to write D over here. D is 158%. So we still have the sales in millions in years 2000 and 2010. Question 11 asks, which of the following is closest to the percentage increase in sales of product A from 2000 to 2010? Question number 12 asks, the sales of product C in 2010 is what percent of the sales of product B in 2000? So I'll give you 6 minutes, and about 2 minutes in, I'll start to solve. Okay, so for number 11, they're asking for the percentage change in product A from 2000 to 2010. So the price, or excuse me, the sales of product A in 2010 will be our final value. The sales of product A in 2000 would be our initial value. So final minus initial divided by initial quantity times 100 would be equal to 41.7 minus 25.2 quantity divided by 25.2 whole quantity times 100. 41.7 minus 25.2 is going to give us a 16.5. 16.5 divided by 25.2 times 100 is going to be 0.655 times 100, which is about 65.5%, which is closest to 65% answer selection A. And for number 12, we're taking the value of the sales of product C in 2010 as the numerator over the sales of product B in 2000. The sales of product C in 2010 were 32.1 million. The sales of product B in 2000 was 23.9 million. So 32.1 divided by 23.9 is going to give us 1.34. 1.34 times 100 will give us 134%. So the sales of product C in 2010 represent 134% of the sales of product B in 2000. If you have any questions on anything that we've done today, then please let me know either in the comment section. Oops, there we go. Camera got it mixed up there. Or you can always contact me on any of my social media accounts. And otherwise, I hope you have a wonderful day. Dr. Tot, you want to say goodbye to everybody? Come on. Let's say bye. Come on, up. Can you go up? He's being lazy today. No, you have to say bye. Can you say bye? Oh, that's good. Very good. Good boy. All right, that's good, right? All right, well, thank you guys very much for watching. I hope you have a wonderful day, and I'll talk to you all very soon.